Hello again and welcome. I am Bins and this is a new video in the Shapez BEASTMAM series. For a few episodes in a row now, we've been recreating the beating heart of this factory's decoder, which is its clock. The last thing we did was scale it up from 1 layer to 4 so that it's now compatible with a full floating piece of up to 4 layers. I did, however, make a small mistake that before anything else I'd like to fix. I announced at the end of the previous video that I would do that, so let's get that out of the way. Here is the clock we built last time. I have made some minimal layout changes to it, but they're so minor that we can safely neglect them. So last time, what did I do wrong? The mistake happened in the situation where a layer has only 1 quadrant on it and we want the machine to forward its input straight to the next cycler. So this is the part of the machine that we have to look at. Now, can you spot what is wrong? If you can't, let me tell you. The way this is currently set up is the following. We decide whether we are dealing with a layer that only has 1 quadrant on it by checking whether this line has a white value on it. And if it has a white value, then this comparing unit will trigger and it will start outputting a 1. But the capital mistake here is that we shouldn't emit a 1. We should be forwarding the pulse. And the reason I didn't notice that before was because I chose my 4th layer to only have 1 piece on it. And in that case, it coincides because we are going to have a constant 1 signal here. And if this module is triggered, then we will also be having a constant 1 signal here. But for any other layer, that won't check out. Let me take an example shape and let me show you what happens. So in this case, we have a 1 quadrant layer on the 2nd layer. And if we go look at the 2nd clock, then we have to start from the top here. So this is the 2nd from the top. The 1 is triggered here and it's emitting a constant signal to the next clock, which is constantly switching its values, even though at the bottom here, we don't have a pulse. So we don't want this to emit a signal. We want this to forward a signal. And the way we could do that is as follows. This is what that should look like. Okay, small mistake, easily overlooked, but it makes a world of difference. So let's try that again. Now, let's reload the shape and see what happens. Excellent, problem solved. Now let's run a few pulses through the machine to see if it works. There we go. So we have 4 layers, 4 quadrants, 1 quadrant, 3, and then 2. Let's see if that corresponds to the outputs we're getting. Let's reset. That looks right, doesn't it? 4, 1, 3, 2. Okay, so pulse. Next. Yeah. That looks good. However, we do have a small synchronization problem, and that is something we still have to remedy. Why is that? Because if a pulse comes from here, then it passes through 1, 2, 3 units. And if it comes from here, then it doesn't pass through any of those units, right? So we need to compensate that. 1, 2, 3. Now let's run a few more pulses. 1, 2, 3, 4, 5. And now let's see if we have a synchronized switch. Looking good. And plop. There we go. That's how we should fix that. Perfect. Alrighty then. Now that we've corrected the machine, we can get going with today's actual topic. Cue the title screen. Chapter 4B, Episode 4. The Float Piece Filter. Alright, let's recap. Initially, we built a rudimentary one-layer cycler with 4 values. That was 3 episodes ago. Then, we expanded on it so that it wouldn't only work for input layers with 4 quadrants, but with any amount of quadrants. The quadrant count of the input is one parameter that this machine needs to be taking into account. And today, I want to have a look at a second one of those parameters. The clock we've built up to here. It has 4 cyclers that run in iterations. The amount of values we load into each of those cyclers represents the amount of quadrants in the input. Each cycler represents one layer of the shape, and since a shape can have up to 4 layers, that's why we need 4 cyclers. However, now let's get back to something that was addressed a few videos ago. In the grand scheme of things, we want this machine to generate a series of floating shape pieces based on the target shape. And there are 6 sets of those floating pieces. There's 1 set of quad floats, 2 sets of tri-floats, and 3 sets of duo floats. And now, we want to make sure that our clock cycles through all of them. Because what our clock currently does is output 4 values if a shape has 4 layers, or 3 if it has 3, and so on. But we want it to be capable of cycling through any kind of floating piece. Even if the shape has 4 layers, we still want to check for tri-floats and duo floats in it. And not only that, we'll actually want to check for all of them in succession. So the way I handled that was with an additional top-level cycler that is actually activated first. Now I think I've stated this in the video about the code shapes too, but I decided to assign a coded value to each of the float types. And these values are the ones we are going to load into our new cycler. So let's have a look at that. This new additional cycler has 6 memory cells, 1 for each value. And while it has a bit of a different layout here and there, functionally, it is just like the other ones. It has a load button, a reset button, and a pulse button. So let's reset the machine first because I was testing this, and then we are going to load the values into the cycler. The first value is output immediately, and then it cycles through all of its 6 values just like the other cyclers do. All right. Let's reset it again, reload the values. Connected to this cycler, there is a row of comparing units, and these comparing units are connected to 4 outputs. And based on the value that the cycler is currently outputting, this mechanism is going to determine which lines get activated and which don't. And in turn, each line corresponds to a layer of our target shape. So this cycler determines which layers of our input shape get passed on to the other cyclers and which don't. So let's reset this machine once again, and then I'm going to connect this wire. and then we're going to see what happens. We have 6 sets of floating shapes, and we have 6 values in our cycler. If I load up the values into the machine, then the first thing that's going to happen is it's going to pass on the lines for layers 1 and 2, which means that the cyclers will now check for duo floats on layers 1 and 2. If we move over to the next value, we are going to enable the lines for layers 2 and 3, and we're going to block the other 2, which means we're going to check for duo floats on layers 2 and 3. Another pulse, another value, duo floats layers 3 and 4. Another value, we are going to check for tri-floats on layers 1, 2, and 3, then tri-floats on layers 2, 3, and 4, and finally, we are going to enable all of the lines, which means that we are going to check for quad floats if we have them. And since this is also a cycler, this just moves around in loops, just like the other ones. All right? Now that we have that, let's connect this new piece to our initial clock. All right, a quick demonstration to show you what we've done up to here. So I've connected these initial converting modules that we built previously that is going to convert the amount of quadrants found on a layer to a shape code. I've put them all side by side, and I've connected that to our new cycler module. So for example, if we take a very easy shape that has 4 quadrants on each layer, then you see that the 4 of them are converted into windmill symbols. This has been connected to our new cycler, and if we load the values into the new cycler, then the first thing we are going to do is check for floating quadrants on layers 1 and 2. So the other 2 lines, they get cancelled. Have a look at this. This is layer 1, this is layer 2. If we send a pulse through this system, layers 2 and 3. Layers 3 and 4, 1, 2, 3, 2, 3, 4, and finally all of the layers. And then that cycles. So now this, we can connect that to our initial module. Oh, I'm a sucker, am I not? This is the problem. I reversed my... I tried to tick synchronize this, but I reversed the ticks, the additional ticks that each of these lines should get. It's 3 here, 2 there, 1 there. And now that should work, shouldn't it? Let's try that again. Nope, still not working. Troubleshooting continues. And there we go. What's the problem? The problem was 1 additional tick. So this tick this tick thing that I talked about, we really need to take that into consideration always, right? Always. It can always mess up something. But either way, so now we have reconnected this the way it's supposed to go. All right, let's reset the machine again. Like so. Except we didn't want this. There we go. And now we are going to enable our floating piece cycle. And what do we see? That now when we send pulses through this machine, we only check for layers 1 and 2. When we press the button here, then we will be checking for layers 2 and 3. But I think you can already spot a problem, and if you haven't, let me tell you. Whenever this happens, we need this to be reset, as a matter of fact. Okay, so we are going to build a change detector on this line, and then we are going to create brief interruptions on these lines again, so that we make sure that the machine is reset. Let's do that. Oh, we keep bumping into stuff. Well, this is kind of nice because this kind of reflects the struggle I've had building this machine. But now I realize there is something else we haven't accounted for, and that is, what if we don't get an input right here? If we don't get an input right here, then the pulse sent through this machine, this first cycler, it should also move on to the next cycler where we do have inputs, because now we are checking the second type of floating layers, which is the one that checks for floating shapes on layers 2 and 3, right? However, the input is here, and since everything is cut off, we don't get any pulses to the next thing. So we actually need to do something else. And the thing we could do is make sure that if we don't have any value here, we transform that into a 0. We could do that, for example, as follows. So the next thing I've done, the thing I've done now, is if we don't get an input value, then we are going to force emit an uncolored dye value to these lines. They don't match with anything, so nothing will get loaded up into the cyclers. But since we do have a value now, what we could do is we can compare that like so. Okay, I think this should do it. Let's test it. Looks good. Looks very good. And now let's test the tick synchronization again. Yep, that works out. So now that we've accounted for that, we can continue to showcase the new cycler. So if we swap this, we should get the top 2 rows And I do see we have a problem here because this line got another pulse. It shouldn't have. Why is that? Let's find out. All right, I've added one extra tick into the system. Let's see if it solves that. So far, so good. Now, let's load up this machine. Yep, that looks good. Now, layers 2 and 3. Oh, we still got a pulse there. Anyway, I think I'm done troubleshooting for this video because otherwise it's going to take indefinite time. But you see how complicated this gets. Now, in any case, we have hooked this up. We now have a selection mechanism that is going to cycle through the different variants of floating shapes. And the thing we want to do now is we've been enabling this machine with buttons by pressing buttons, but it should actually trigger itself. And the way it should trigger itself is if one of these mechanisms that we loaded up reaches the end of its cycle, then it should send a pulse to that cycler module. So as a matter of fact, we can put this right here. And then this output line connects all the way back to this one. That should be sending out a pulse. Okay. New test. We load up the shape. We get 4 values. Now we enable this machine. We check the bottom 2 layers. And the machine is tilting now. This has to do with the fact that enabling this machine will send a brief pulse. That's why it doesn't work. So as a matter of fact, you know what? I'm going to save you the details. I did encounter this problem before, and this is the reason why I built these additional sets of lines. They are going to try and counteract. They are going to make sure this system, for example, and also this one, it's going to make sure that we don't get these false positive pulses when the machine is starting up. So again, I'm going to save you the details. I think it's beyond the scope maybe of what's interesting for this video. But either way, we have built a very important module in this machine, and we've connected it to what we've built previously. So I think we are progressing nicely actually to showing you how much of a challenge this is. You see that whenever we add something to the things we've already built, there are complications. It wasn't necessarily my intention to demonstrate these complications in this video, call it a lack of preparation, but on the other hand, it did, and it kind of illustrates well how much of a search it has been to make this machine reliable and sturdy so that it fully functions, because the slightest detail, the slightest oversight, as we've demonstrated also at the end of the previous video, the smallest oversight can make the entire machine run haywire, and it takes a long time to troubleshoot to find out what that is. But I think we can wrap it up here. So another module built, another piece added to the construction we are building together. And with that said, I hope you found it interesting. This machine is getting very complex and we are discovering it together. So I hope you are excited for the upcoming videos where we will continue to explain, figure out, discover together how this machine actually works. If you are interested to see that, then please do hit the subscribe button, hit the notification bell so you get those updates, all that good stuff. And if you like this video, I always greatly appreciate it if you give me a thumbs up, if you leave a nice comment. And with that said, I hope to see you soon. For today, I am signing off. Take care. Bye.